Hello, everyone. The topic for today, and actually for the rest of the symposium or the workshop, is this. How can we join or bridge sustainable agriculture with nutrition and health? On one hand, you have climate change and what's been referred to as climate-smart agriculture, but there's this other concept of nutrition-sensitive agriculture. And the question, of course, is, are those two compatible? And so my job today is to provide you with some of the common language that we use in nutrition, provide you with some points of view for nutrition, push the envelope a little bit and provide you with some provocative viewpoints for discussion, and then look at the potential points of attachment between agricultural modeling and a societal good, by which I mean sustainable food and nutrition security. So let's start with some definitions. What is sustainable nutrition security in the view of international agencies? So the World Bank has defined food security as access by all people at all times to enough food. Some people have interpreted that as meaning more food and more calories. However, later definitions focus less on calories as they do on nutrition, safety, and cultural sensitivity. So notice the World Food Summit already was talking about physical, economic, and social access to sufficient, safe, nutritious food, and an FAO definition, which I use as my standard, talks about foods and diets which are nutritionally adequate, economically affordable, culturally acceptable, accessible, healthy, and safe, but also sparing of the natural and environmental resources. So first of all, bear in mind, it's a very important point, that health and nutrient density are integral components of food and nutrition security. You might think that sustainability is all about the environment. For us nutritionists, it is not. It's merely one of the four domains of sustainable food and nutrition security. The others one are nutrition, economics, culture, and then the environment. So the notion of sustainability is not necessarily the same for everybody. So how do we do this? So one position expressed by some agencies has been that agriculture has done a lot to minimize hunger, increase crop yields, and produce more food. The opposing viewpoint is that we need to change the nutrient to calorie ratio in a global diet, because malnutrition now can take different forms. It can be lack of calories, but it can also be ample calories but lack of nutrients. Hence the concepts of hidden hunger and the so-called dual burden of disease, where in the same country, developing country, you see both malnutrition and stunting and overweight and obesity. So we need a shift to what has been called nutrition-sensitive agriculture. And here we need to weigh the potential mechanisms of how climate change can impact agriculture and can impact people's diets. And one very compelling idea has been to emphasize extreme weather events, food shortages, catastrophes, price spikes, price volatility. In other words, not what will happen in year 2080, but what might happen next year. This is one way to get the attention of potential clients and funders and stakeholders. The other issue, which I have been identifying as a priority, is water shortage. I think this is a huge, big global issue, perhaps even more important than greenhouse gas emissions. The input and the metrics for that are not quite worked out. I'll come to that point. Then you have the rising atmospheric carbon dioxide levels and the potential consequences. And then if you go further into the environmental components, you have land degradation and pollution. But in my opinion, we ought to be focusing on water issues. And here, United Nations UN Water is actually pointing to the fact that most of the groundwater withdrawals are for agriculture. New York Times recently emphasized, lawns in Beverly Hills. That is not the major use of water in the United States. And there are places which have physically very little water and other places which have water, but the water management is there. So this is called the economic water shortage. And you know more about this than I do, but this is now a slide from the United Nations and from FAO showing that water withdrawals for agriculture are really the major use of water in Africa, South Asia, and Asia, Southern America. In North America, it's a bit less. There is more industry and municipal use, but globally, 70% of water withdrawals are from agriculture. Huge big issue involving multiple countries, issues of diplomacy and public health come into it. So for example, I just read a paper in The Lancet about how rising global carbon dioxide emissions may reduce the zinc content of plants in India in year 2050. I would say, given the water withdrawals in Southeast Asia, this is the least thing that you need to worry about. There are going to be many, many other problems which will precede that. So this is how modeling really needs to look at what else is happening in a given country. So there's some nutrition paradoxes which I want to explain to you. First of all, grain crops, and that means rice and wheat and sugarcane and sugar beet and others, provide inexpensive calories, but they can be nutrient poor. So that a diet high in cereals and legumes can actually not have sufficient nutrients and not be the optimally sustainable diet for the population. And in fact, the consumption of animal products is going up. These are frowned upon by the public health sector, but the fact is that they are more nutrient rich, but they carry a higher environmental cost, and they are not necessarily as affordable. So you have this interesting paradox. The most environmentally sound plant foods are not nutritious. In fact, based on a number of reports, the plant food with the lowest land, energy, and water footprint is in fact sugar. But by FAO definition, a sugar-rich diet is not sustainable. So that's a bit of a kind of paradox for nutritionists. We like to think that locally grown tomatoes are the most sustainable plant food. Actually, they are not. So not all nutrient-rich foods are culturally acceptable. So you deal with local and regional differences. And then bear in mind that each country is undergoing rapid nutritional transition, and eating habits are evolving very rapidly. So as I say, there is no point worrying about zinc in 2050. Other things will come into play well before that, and they need to be taken into account. So, for example, I'll just give you an example. This is an economics example. So these are countries with highest obesity rates. The global thinking is that cheap, empty calories, especially sugar calories, contribute to the global obesity epidemic. I'm identifying South Asia and Southeast Asia as the future obesity hotspots for reasons that have to do with agriculture, food production, and of course economics. And the reason is that these are places where population is moving rapidly into cities, and these are cities of 10, 20 or more million people, which are generally poor. So if you have an urban agglomeration of 20 million people who have to be fed, what are they going to be consuming? Clearly, they are not going to be consuming fresh salads and organic produce. What will they be fed? And just do a very simple mathematical calculation. If you have a city of 10 million people, and each of those people consumes 2,000 calories per day, just a model, if the energy density of the diet is 1 calorie per gram, that is the average energy density of the American diet, excluding beverages, then you have to produce and distribute 20,000 tons of food to be distributed daily. So in a place like São Paulo, you would have to distribute 20,000 tons of food daily. Just pure distribution to an urban population which is cut off from the means of food production. But if the dietary energy density increases to 4 calories per gram, in other words, to cereals, added sugar, and added fat, and fried foods, then the distribution costs and complexity drop to 5,000 tons per day. And so these are going to be major, major economic pressures, especially since the grains and the added sugars and added fats are really much cheaper. Take a look at the American prices on the left. We're looking here at the water content on the top panel. On the y-axis, notice that vegetables and fruit are 90% water. Water contributes no calories, no nutrients, but it does contribute to the cost of distribution, cold chain, and so on. It's perishable, which means diets composed of foods on the left will also produce a greater amount of waste. It is estimated that 35% of the food we consume is actually wasted. So think in terms of waste as well. Foods on the right, the fats and oils, the grains, the processed foods are much cheaper, longer shelf life, more sustainable, more energy dense, but not as nutrient rich. So you have another paradox of energy density, cost, preferences, nutrient density, and all of those things need to be integrated in the type of modeling that we do for diets which are nutrient rich, affordable, culturally acceptable, sustainable, and environmentally friendly. And my question is, do such diets even exist? Some compromises will need to be made, and such compromises then will involve the type of modeling that you do. We will not be able to do this without some degree of modeling, because there are so many variables all simultaneously moving. So just a few words here about how developing countries are changing their diets. You've all heard the term nutrition transition. You're very familiar with that. These are the conditions under which a diet of a developing country is becoming less reliant on staple grain crops and includes more animal foods, more sugar, more added fat, more processed foods, but also more vegetables and fruit. So I always go back to the classic FAO picture from the 1970s, where you look at the percent of calories provided by various nutrients. That's on the horizontal axis. On the vertical axis, you have the continuation from the poor to the rich countries. So notice that back in the day, 1970, the poorest countries really had a diet based on staple carbohydrate starchy crops with very little sugar, very little fat, virtually no animal fat. Whereas the rich countries had a diet which was much more rich in fat, mostly animal fat at the time, more sugar, and the only thing that changed about protein was approximately constant, was that plant protein was in fact replaced by animal protein. That was the situation in 1970. When we come to 2000, this is the paper I did with Barry Popkin some years ago about the nutrition transition. Notice that two things happened. The vegetable oils, soy, and the sugarcane, sugar beet, became uncoupled from socioeconomic status by country and are essentially swamping the globe, which means even the poorest nations have now access to added sugar, added fat, cheap vegetable oils, in fact, plenty of cheap calories, but relatively fewer nutrients. Consumption of meat is still tied to socioeconomic status. Added sugar consumption was actually very heavily tied to urbanization. In fact, if you're thinking of what will people eat if the agriculture suffers from climate change, my pessimistic thought is that they will be eating more sugar. And in fact, as eating behaviors has evolved here from 1970 to 2005, notice that the consumption of staple grains and crops has declined. The consumption of animal products has decreased. And there are some other aspects of nutrition transition which we can discuss later on. So if you're modeling staple grain crops and trying to increase yields and increasing production, note that the consumer, the global consumer, is not following along. The global consumer is following along when it comes to sugar and fat, some of which are being fortified. So in fact, there are two schools of thought here. We'll talk about those later on. On one hand, there are people who say, FAO, that we should be promoting biodiversity, local smallholder agriculture, local farms, and so on to maximize the nutrient content of local diet. And on the other hand, there are people who say we should be growing cheap commodity crops and fortifying them with every vitamin and mineral known to man at this time. So these are essentially the viewpoints of, on one hand, the FAO, on the other hand, the Gates Foundation. I'm not saying one is right, one is wrong. I'm saying these are two dichotomies. The solution lies someplace in between. Again, there is going to be a need for modeling. Just a couple of things about the cheap calories. We usually think, this is not entirely correct, that about 3,500 of extra calories that you don't need translate into approximately 1 pound of extra body weight. So here, at global food prices, even at 25 cents per pound at world market, sugar will give you 7,250 calories per dollar, which is kind of amazing. Empty calories to be sure, but calories nonetheless, which means you will not be hungry. So this is essentially the secret of why sugar and added fat still hold sway. And at $1.20 for the fats, soybean oil provides you with 7,500 calories per dollar, which means for $2 you get 15,000 calories, which means enough for an adult for a week of completely empty calories, but they're cheap. So this is why many nutrition scientists are coming out saying we have way too many calories, we do not have the nutrients, and the nutrients that we want to have in our diet carry an environmental cost. And so this is where things become, what was the word just you used? Fuzzy. Very fuzzy. So the Barilla Foundation produced this double pyramid, which is a brilliant infographic. It shows you the foundations of the Mediterranean diet, the fruits, the vegetables, the grains, the olive oil in the center, the pasta, and then the meat, and so on at the top. And the inverted pyramid is the environmental cost of those things. And according to the pyramid, this environmental cost was calculated based on land cost, energy cost, water cost, greenhouse gas emissions, and so on. But if truth be known, the data for all those metrics are kind of missing. So it was brilliant, they're probably right, but it really wasn't based on terrifically hard science at the time. So what I have produced, and this can be discussed at length, is this. These are the potential models and measures for sustainable nutrition security in 4 principal domains. And this could be a kind of blueprint for future discussions because we're looking at inputs, food metrics, dietary pattern metrics, and outcomes. So here I'm looking at the 4 domains: nutritional, economic, sociocultural, and environmental. And each of those requires a specific set of inputs and a specific set of data and metrics. So for nutritional, you have to have nutrient composition databases, and you have to have dietary intake data for multiple countries. For economic, you have to have some handle on the cost of food, the cost of crops, the cost of calories, and the cost of nutrients. Then you have, for the sociocultural patterns, you need to have some idea of what foods are acceptable or not to a given population. And again, you can get those data from patterns of consumption for a given country. And then for the environmental aspect, we've been looking at life cycle analysis databases for greenhouse gas emissions. And there are some other data on water, land, and energy use. And we're moving as far as transportation and even waste, on which very few data are available. And those data can then be put together into metrics and then nutritional epidemiology, which can then be linked to potential health outcomes. So I'm going to leave you with this kind of blueprint for the domains of sustainable nutrition security, the need for metrics and data, any type of modeling that can be used. I'm approaching this very much from the standpoint of nutrition and nutritional epidemiology. You will be approaching it from different viewpoints, and I'm hoping at the end of the workshop we'll all come together and come up with a unified approach which combines all those ideas together. Thank you.